This is Masato Murakami from IMES. Today I'd like to talk on low carbon society. Is it a good choice? This slide shows a very famous doomsday scenario. Emission of carbon dioxide causes global warming, and it leads to extreme weather, and finally it causes destruction of the Earth's environment. Doomsday. So people are saying CO2 is the enemy. But the key issue here is the question: how does CO2 increase Earth's temperature? Well, the answers from many people. The CO2 can absorb and store heat. If so, it's very easy to understand. But in fact, it's not correct. CO2 cannot absorb heat. This is very important. What CO2 absorbs is infrared radiation, and heat is not equal to infrared radiation. But people may ask me, oh, infrared is heat, isn't it? No. Well, but then what about an infrared heater? It's heat. Well, in fact, infrared is invisible light and a type of electromagnetic radiation. You feel hot when infrared radiation hits you because liquid water in your body absorbs infrared radiation and converted its energy into heat. So infrared is not heat. And temperature reflects the motion of matters, like hot gas molecules are moving at very high speed. Water molecules in hot water moves at very high speed, so that's why you feel pain when you put your hands into it. And what is the speed of gases in the atmosphere? At 25 degrees C, hydrogen gas moves at 1930 meter per second, 1930 meters per second, and oxygen 440 meters per second, faster than the speed of sound. It's amazing. Now let's go back to the main point. CO2 can absorb infrared radiation, and the gases that absorb infrared radiation are called greenhouse gases, like water H2O, methane CH4, and CO2. And nitrogen and oxygen are not greenhouse gases. Then what is the difference? Well, it depends on the interaction with electromagnetic wave. Well, electromagnetic wave is an oscillation of electric and magnetic fields. And here it's important to look at oscillation of electric field interact with greenhouse gases. The gases that do not absorb infrared radiation, like nitrogen and oxygen, there's no interaction because there is no polarity in electric charges. Well, in the case of water, I show you the structure here. This is the most powerful greenhouse gas. And this, structure like Mickey Mouse is the source of weird properties of water. And here it's very important. There is a polar molecule. That means positive charge and negative charge are not uniformly distributed. And this is the schematic illustration of interaction between H2O and microwave oven. Well, microwave is a type of electromagnetic radiation, and because of its polarity, water molecules can react with this plus minus oscillations of microwave. And there is a heat because there is a friction between different molecules. Here it's important. Vapor and ice cubes cannot be heated with microwave oven. In a vapor, it's gas, so no interaction with other molecules. In the case of ice, molecules cannot rotate because it's rigid. So only liquid water react with microwave. Then what about carbon dioxide? In fact, CO2 is a nonpolar molecule because there is no non-uniform charge distribution. And the polar molecule charge distribution is not uniform like this photo. If so, how CO2 observe electromagnetic oscillation? It's very interesting to look at, what's happening. One thing is so-called asymmetric stretching vibration. The distance between carbon and oxide changes asymmetrically. And then there is a polarity in electric fields. That's why CO2 can interact with infrared ray, but the wavelength is 4.2 micron, not other infrared. There is another vibration corresponding to the infrared radiation. That's bending vibration. And like this, if the angle OCO changes like this, then CO2 can interact with infrared. But in this case, the wavelength is 15 microns. If you look at the infrared absorption spectroscopy for CO2, one can see there is an interaction between IR and CO2 at two places. For infrared rays with wavelengths of 4.26 micron and 15 micron. But here we should notice this fact. CO2 is excited by the oscillation of infrared ray, but this excited state is unstable, and the lifetime is around 10 to the minus 9 seconds, very, very short. And then excited state emit infrared ray and goes back to the ground state. So this is very important aspect of this excitation. Then what is the global warming mechanism due to CO2 emission? Well, infrared radiation emitted from the Earth's surface to space is returned to the ground by CO2. This is the mechanism. Well, let me show you this slide. This shows how the temperature of Earth's surface is determined. There is a heat input from sunlight, and this is known as solar constant. It's constant. But if Earth receives sunlight, its temperature goes up. So there is a heat release from the Earth's surface to the universe. So equilibrium Earth's temperature is determined by the simple equations: heat input from the sun and heat output to the space. Then how we calculate the heat output? There is a very simple physical law. It's called the Stefan-Boltzmann law. The heat output is proportional to T to the fourth power, and here T is the temperature of the Earth's surface. Very simple. And simple calculation gives us the Earth's surface temperature is minus 18 degrees C, 255 K, but of course it's too cold, right? Then what's happening? Well, here is the point. The heat released to the universe, a part of it returned to the Earth. And due to this heat return, the Earth's temperature is 15 degrees C. And what is the source of this heat returning mechanism? That is greenhouse gases. And CO2, of course, return the heat to the Earth's surface. But here, well, it's important to notice, heat is not returned. It is infrared radiation. But people using heat because it's easier to understand. Now, the schematic illustration shows absorption and emission of infrared ray by CO2 molecules. Well, when infrared radiation coming from the Earth's surface, CO2 observe this IR and vibrates. But the excited state, the lifetime is very short, only 10 to the minus 9 seconds, right? And then immediately CO2 emit IR. But in this case, we don't see any returning process. This is also a very interesting aspect of physics. When CO2 receives infrared ray, there is oscillations of electric field, plus minus, and this oscillation emit electromagnetic wave, in this case infrared ray. And in this case, infrared rays is emitted to the direction of the space and also to the direction of Earth's surface. We call it backscattering. So, half of infrared radiation return to the Earth. Very interesting. So there is a simple model. If there is a greenhouse gases in the atmosphere, 50% of the infrared radiation goes out to the space, but 50% coming back to the Earth's surface. Then if we calculate, well, if we take into considerations to returning process, the Earth's temperature is 31 degrees C. It's too high, right? Well, it's easy to understand, of course, greenhouse gases are not 100% in the atmosphere. So we have to consider its fraction. And as a result, equilibrium Earth's temperature is 15 degrees C. So here is one question. If the CO2 is the main source of the infrared radiation to return to the Earth's surface, why is the desert so cold during night? During night, the heat or infrared radiation coming from the Earth's surface goes to the universe or space. But if there is CO2 gases, it will return infrared radiation. Why it doesn't work? Well, there is another interesting feature, that's radiative cooling. Heat is radiated through IR into space from the Earth's surface. And if there is no mechanism to return this irradiation, the ground temperature goes down. And in fact, It's very cold in inland regions. And the coldest point in northern hemisphere is not the North Pole, but Oymyakon in Russia. And those latitude is only 63 degrees C. The temperature went down to minus 71 degrees C because of radiative cooling. Then what about the greenhouse gases? Well, it's also known that radiative cooling is not observed on a cloudy night, and the cloud is made of water droplets. So it looks like, a cloud or the water droplets is the main player to return the heat back to the Earth's surface. This is very interesting data. Absorption of infrared radiation by liquid water. If the thickness of liquid water is 1 millimeter, then almost all the infrared radiation is absorbed like this. So it looks like water, H2O, is the main player. This is the last slide. Shows atmospheric components. If there are 10,000 gas molecules, 7,810 nitrogen, 2,090 oxygen, and 93 argon, and only 4 carbon dioxide. And this is the case of dry air. But in most cases, the atmosphere contains water vapors or water droplets, and the fraction is 30 to 300. Well, is CO2 the main culprit to cause global warming? Please think it yourself based on your scientific knowledge. Thank you very much for your attention.